Hi, welcome to another edition of Admiral Science. I'm your host, Mr. Allen, and today we're going to be discussing ionic bonds. Alright, so what should we already know? We should pretty much already know what what valence electrons are. We've been talking about it for a couple of segments now. We know that valence electrons are the electrons on the outermost energy level, the number of electrons on the last level. Let me get my pen. All right. So and it's determined by the group. So this is group 1. This is group 2. This is group 3. This is group 4. This is group 5. This is group 6. I'm sorry. I did it again. 13, 14, 15, 16, 17, 18. And I did this on a previous video where I started writing the actual valence electrons instead of the group. But this is the groups. These are the groups on the periodic table. This is the groups. And this goes for all the groups on the periodic table. All the groups on the periodic table. Alright, so this is for all the groups in group 1. For all the elements in group 1, they have 1 valence electron. For all the elements in group 2, they have 2 valence electrons. For all the elements in group 3, they have 3 valence electrons. For all the elements in group 4, they have 4 valence electrons. 5 for 15, 6 for 16, 7 for 17, and 8 for 18. And here, these structures right here, where you see the dots of the valence electrons, these are Lewis dot structures. And we talked about that in the previous segment, Lewis dot structures. And they help us to determine the valence electrons, because valence electrons are important in chemical bonds. So valence electrons are important in chemical bonds. And on my previous segment, we talked about how the valence electrons, that the elements all want to achieve the holy grail, the 8. All right. Like all the elements in group 18 that have a complete set of valence electrons, they want to be completed. So everybody from group 17 on down to group 1, they want to feel completed. So they want to achieve the octet rule of 8. Alright, so we did Lewis dot structures yesterday, and we know, for example, fluorine, which has 7, it's in group 17. So it has 7 valence electrons, 1, 2, 3, 4, 5, 6. And this line represents that they share an electron. So this fluorine has an electron, this fluorine has an electron, and they share, and this line simply means that they're sharing their 2 electrons. And this is what we call a covalent bond, but we won't be talking that much about covalent bonds today. Alright, so, but there are 2 types of bonds that we talk about in 8th grade physical science, one being ionic bonds and the other being covalent bonds. Alright, now ionic bonds is, just as the name applies, a bond between ions. Alright, so, and we'll get into what ions are in the short term. Ions are elements who have gained or lost an electron. So if you need to write down, ions are elements, and you're going to see this on the next slide, that gains or loses an electron. Alright, so here is a sodium ion. Here's the normal sodium, because remember, all the elements on the periodic table are stable until they start doing weird things, such as losing an electron. And you don't lose the electrons in the middle. You lose the electron that's on your outer shell. So any element that loses or gains an electron, they gain it on their outer shell. So sodium loses an electron on its outer shell. And then when you lose an electron, because remember, electrons are negative. Electrons, I don't know why these eraser marks keep coming up, these streaks. But when you lose an electron, because electrons are a negatively charged particle, if you lose a negative, what essentially do you become? If you lose a negative, you become positive. Think about it in life. If you drop your negative behavior, you then start becoming a positive person. Alright, so when you lose an electron, you become positive. If you gain an electron, you gain negativity, then you become negative. Alright, so an ion is a particle or an element with a positive or a negative charge. Remember, on the periodic table, elements are stable. They're neutral because they have the same number of protons as electrons. And so that balances them out. That keeps them neutral. But when you have an ion, and because remember that all the elements want to achieve that octet rule, that 8, that magic number of 8. So elements will do whatever they can to get this 8. So when they start exchanging electrons, and take for example sodium chloride, it's easier for sodium to give away one of its electrons than for chlorine to give away 7 to them. So this one will not happen. This one would. So, and because now you have a positive, because remember it lost an electron, so it became positive, and this gained an electron, so it became negative. And when you have a positive and a negative, what happens? They attract. And NaCl is another way of saying salt. It's your table salt. And so the bond between a negative and a positive in an ionic bond is how we have our table salt. Alright, so now chlorine now has their complete octet rule of 8, and so does chlorine, because now, but it may have dropped in orbit, but it still has a complete set of 8. 1, 2, 3, 4, 5, 6, 7, 8. So it achieved its 8 by giving away an electron, and chlorine achieved its 8 by taking in electrons. Alright? So ions form when an atom gains or loses an electron from its outermost energy level. Remember, that's important, that it has to happen from the outermost energy level. These don't change. The ones already in there, these don't change. That's why valence electrons are important, because your valence electrons are the electrons on the last energy level. Alright, they determine the chemical bond. Alright, so ionic bonds form when electrons are transferred from a metal atom to a non-metal. Alright, so we have metal and non-metal. For example, lithium, we know lithium is a metal, and fluorine is a non-metal. And we all want to achieve the octet rule. Remember, for the first orbit, the octet rule or their rule of completion is 2. Alright, so lithium, being that it's in group 1, has 1 electron. Fluorine, being in group 17, has 7 valence electrons. So they have 1 valence, and these X's represent the electrons. And we know that lithium, because it has 1 electron on this last level, has 1, versus fluorine that has 7. So it's easier for fluorine to take that 7 than to take that 1 than to lithium to take that 7. So being that lithium now can give away their 1, they're now complete with their 2. And fluorine is now complete with its 8. And being that because it lost an electron, it became a positive, and because fluorine gained an electron, it became a negative. You now have that attraction for lithium fluoride. Alright, so remember that our periodic table, so these elements right here, your metals, the blues, all the ones in the blues, these metals will combine with a non-metal to form an ionic bond, because the goal of everybody is to be like group 18 and be complete. Alright, they want to be complete. So when an element gains an electron, it becomes negative, and when an element loses an electron, it becomes positive. So when you lose the negativity, you become positive. When you gain negativity, you become negative. The same way in life. When you're around positive people, when you drop your negative baggage, you then become positive. Versus when you gain negative baggage, when you gain negative people, you then become a negative person. All right. Same thing with elements. Elements are just like people. All right, when they gain a negative, they become negative. When they gain a positive, they become positive. All right, so lithium, during the ionic bond between lithium and fluorine, lithium became positive because it lost an electron, and fluorine became negative because it gained an electron. All right, this is the electron that it got from. This is the electron it got from lithium. Alright? So, some properties of ionic compounds is that ionic compounds form a crystal lattice structure. When ions bond, they form a repeating three-dimensional pattern called crystal lattice. And when you look at salt and you look at it very closely, you'll see that it's a crystal. It is in fact a crystal. And with many ionic bonds, they form this crystal three-dimensional structure. Another property is that it's brittle, and we talked about brittleness the other day. Remember, brittleness is easily broken, and crystals of ionic compounds are hard and brittle. All right, they are more likely to break rather than bend when hit with a force. So if I were to hit a hammer against salt, it's going to break, just like up here. It's going to break, and it's going to break very easily. All right, it's not going to require much force. Sort of like the me slamming a hammer on chalk. It's very brittle. It breaks easily. And then ionic bonds have high boiling points. Ionic bonds have extremely high boiling points due to the strength of the ionic bond. It requires a high boiling point. So ionic bonds are very strong. All right, and so because they're so strong, and when you heat stuff up, you're basically breaking it apart or separating it, but in ionic bonds, because they're so strong, you have to have an extremely high boiling point to be able to break the bonds apart. Alright, and then properties of ionic bonds continued. Ionic bonds do not conduct electricity as solids. Ionic bonds require a liquid source to conduct electricity. So here's ionic bonds as solids. Alright, remember, in order for electrical current to be achieved, the negatives will flow to the positive sides, because we all like our opposites to attract, and the positives will flow to the negative side. But because they're so tightly packed in ionic bonds, they can't move. Whereas in an aqueous solution or a water-based solution, then you can free up the spaces in between the bonds, and it can then electricity can flow more fluidly. All right. So the ions move to the positive ions move to the negative terminals, and the negative ions move to the positive terminals. Alright. Now match the likely pair of ionic bonds. So remember that octet rule. Alright, they want to achieve that 8. So based off here, which elements will achieve their 8? I will give you some time to answer. Just mark it on your paper. Or matter of fact, pause me now. Forgive me for the streak. Alright, so let's see. If you said that sodium, which has 1 valence electron because it's in group 1, and you combined it with fluorine. Why? Because fluorine has... Alright, so if you said 7 valence electrons with sodium's 1 valence electron, you were correct. Alright, and then we have calcium, which has 2 valence electrons. Why? Because it's in group 2, and it's going to combine with, if you said oxygen, you are correct, because how many valence electrons does oxygen have? 6. Alright, and then lastly, aluminum, which has which is in group 3, and nitrogen, which is in group 5. They match the rule of 8. Alright, so remember, it's the octet rule. Sodium will give their 1 to fluorine, calcium will give their 2 to oxygen, and aluminum will give their 3 to nitrogen to form our ionic bonds. And these are our metals, and these are our non-metals. Alright, now let's name our ionic compounds. Remember, if you do not know, 2 elements make an iod, and 2 elements plus oxygen make an 8. Alright, so today we're just going to do the ides because the 2 elements together form an iode. And let's look at our compounds that we just made. When we combined the sodium with the fluorine, it became sodium fluoride. When we combined the calcium with the oxygen, it became calcium oxide. And aluminum nitride was formed when we had the aluminum with the nitrogen. Remember that because they lost an electron, they became positive and they became negative. They lost an electron, they became positive and they became negative. They lost an electron, they became positive, they became negative. Alright? This has been another episode of Admiral Science. I look forward to working with you on the next episode of Admiral Science. Again, I'm looking for volunteers, for students to help me next week with more of Admiral Science videos. Any questions, please leave it in the box below and I will respond in accordingly manner. And if you need additional help, please, I stress that you review the videos again and again until you feel comfortable that you will be able to master ionic bonds. And be sure to look at the other videos if you are missing any concepts. I encourage you to look at my other videos. And this has been another episode of Admiral Science. I bid you farewell.